Alright, in this class we'll be discussing about the 11th lab program, that is on graphs. The problem definition is design, develop and implement a program in C for the different operations on the graph of n cities. City refers to the node here. First thing is we should be able to create a graph of n cities by using adjacency matrix. You should make use of adjacency matrix representation and create the graph for n given cities, n different cities. Now then you have to print all the nodes reachable from given starting node, any given starting node in a digraph, that is in a directed graph. That means we are discussing about directed graph here using DFS and BFS. The concepts about these DFS and BFS theoretical concepts were already covered in the theory class. Now I am going to give the demonstration, practical demonstration. So this is the function for depth first search, DFS, and this is the function for breadth first search. Now I will start the program execution from the main function. So as we know that the execution of program will start from the main function, right? And here we are declaring the local variables I, j, source flag equal to 0, and adjust ADJ array. It is 10 row and 10 columns array, which is used to store adjacency matrix, and this is used to store whether the node is visited or not. And earlier the visited array is being initialized with zeros. Everywhere it is 0. What it indicates? None of the nodes are visited, and n indicates total number of nodes in the graph. So this is just clear the screen in the Fedora environment. While these conditions are true, give different options to the user. What are the different options? This will be printed as it is. Choice 1 to create a graph of entities. Choice 2 to print the reachable node form using BFS. Choice 3 for DFS. Choice 4 for exit. Once the user gives the choice will be stored in the choice variable and the switch statement will be executed. The switch statement will be cross-verified against the choice. Case 1, these statements will execute it. Case 2, these statements. Case 3, these statements, and 4 for exit. Right? Now let us see the case 1. Case 1 is for just creating the adjacency matrix. Because once we have the adjacency matrix, then only we can perform DFS and BFS. Now enter the number of cities. Ask the user to enter the number of cities. In this case, let us say 4 cities. So I'll consider one graph here. I'll consider one graph. So let us take this graph, usually what we have seen in theory. 0, 1, 2 and 3. So again this is the graph and this is having some directions like this. So from 0 we can go to 1, 2 and 3. Then from 2 we can go to 3. Then from 1 we can go to 2. Then from 3 we can go to 1. So this is one sample graph given digraph. The graph is given to us. And what will be adjacency matrix for this? Adjacency matrix, as we have already studied, this is the adjacency matrix for this given graph. So adjacency matrix, if there is a row, there is a edge from one node to another node, then the entry will be 1, else the entry will be 0. 0, 1, 2, 3, then 0, 1, 2, 3. So is there edge from 0 to 0? No. So this is already covered in the theoretical part. So directly I will write the adjacency matrix. 0, 1, 1, then 0, 0, 1, 0, 0, 0, 1. This is the adjacency matrix for this given graph. 0, 1, 0, 0. So this is what is adjacency matrix. This is what is adjacency matrix. And now enter the adjacency matrix. For every iteration of I and j, the adjacency matrix is being created and it is being stored in the array called adjacency ADG. That is, this is what is ADG. Adjacency matrix is read successfully and it is stored now. Now what we have done for the given graph, adjacency matrix is ready, which is known to us. Now we have to perform DFS and BFS on this adjacency matrix, right? Now I'll go to program. For case 2, what is case 2? Case 2 is for BFS, breadth first search. Now for breadth first search as well as depth first search, we should give the source vertex. That means from which node we are starting the operations. You should give the source vertex. Now enter the source vertex to start the traversal, and that will be stored in the variable called SRC. Now for example, in our case, I will consider the source vertex, that is SRC. I will consider source vertex as 0. That means we are starting the traversal from 0 and we are trying to reach all other nodes. We are trying to reach all other nodes. So source vertex is 0. You can take any other node also. For explanation purpose, I am taking source vertex or starting vertex as 0. Right? Now the list of vertices visited are, that will be printed as it is. Now BFS method is being called by passing parameters as source is 0, adjacency matrix, what is n? N is 4 because there are 4 nodes in the graph. So how the function is being called? BFS of, which function we are calling? We are calling function that is breadth first search of SRC, comma, adjacency matrix and n. SRC, comma, adjacency matrix and n. That is nothing but how it will be called? BFS of what is source 0? We have given source as 0. What is adjacency matrix? This adjacency matrix will be passed as the parameter here. This adjacency matrix. And then what is n? N is number of nodes 4. Now let us, the control will get transferred from here to the function definition of breadth first search, that is BFS. Let us go to definition. This is what is the definition of breadth first search. I'll just try to increase the font so that you can see. Right? Now adjacency matrix is received here, n is received here. As we know that breadth first search will make use of queue data structure, depth first search will make use of stack data structure. Right? Now queue is being declared with 20. So for our understanding purpose, I'll declare some queue here. Queue which is of any size. In this case 20 elements we can store, but I am taking only these many locations 0, 1, 2, 3, 4. Front equal to 0, rear equal to -1. That is what the initialization we do usually. That is front is pointing here and rear is pointing to -1. Front is pointing, rear is pointing to -1. UV variables, then visited of 10 equal to 0. So what it indicates? Visited array you create of size 10 and make everything as 0. What it indicates? None of the nodes are visited now. We are starting from 0. We are starting from 0. So visited of 10 is equal to 0. One second, I have some other plan. What I'll do, I'll copy this function. I'll copy this function. This and I'll paste it here. So that I need not change the page again and again. This is the DFS function. All right. Now these, one second, I'll take this properly to the next page. This is the adjacency matrix known to us, and the Q is here. This Q, I'll take it here, and meanwhile, I'll take this adjacency matrix here. Right. So what we have declared a Q of some size. Just beside the code only, I will write the tracing part so that we can understand. What is our adjacency matrix? Adjacency matrix, I am going to rewrite it here. Right? What was the adjacency matrix? 0, 1, 2, 3. 0, 1, 2, 3. The entries were 0, 1, 1, 0, 0, 1, 0. Then 0, 0, 1. Entries were 0, 0, 1. Then 0, 1, 0, 0, 0, 1, 0, 0. This was adjacency matrix, right? Now let us start make front to point to 0 and rear to point to -1. Visited, an array you take as visited and initialize everything to 0. Initialize everything to 0. It is of size 10, but as there are only 4 nodes, that will be sufficient for us. 0, 1, 2, 3, 4, 5, and every entry is made 0. What this indicates here is node 0 is not visited, node 1 is not visited, node 2 is not visited, node 3 is not visited. So none of the nodes are visited now. So that is the initial entry. Now, as we are starting from node which node 0, as we are starting from node 0, it is understood that that is visited. It is understood that that is visited. So that's what we are doing. The first line, q of plus plus rear, q of plus plus rear, that is increment the rear by 1. Now rear will be cancelled and rear will be made to point to this node. In this location, what you copy? Copy the source. What is source here? Source is 0. Source is 0. What this indicates? Node 0 is successfully visited now. Because you are starting from node 0 means obviously it is visited. You are starting from node 0, obviously it is visited. Now make visited of source as 1. What is source? Source is 0. Visited of 0 as 1. Visited of 0 as 1. Instead of 0, I will erase it and I will make it as 1. That I will rewrite it properly. Now this becomes 1. The entry 1 indicates that that node is successfully visited. This line. I have explained this line now. Then this is what is the print output. This is what is the output which will be printed. I will write the output here on the screen. What it is simply printing the source. What is present in source? We have 0. So this is what is the output. Now let us repeat this. While front is less than or equal to rear, the condition is true. Front is also pointing to 0. Rear is also pointing to 0. The condition is true. The condition is true. Then obtain the next node. Obtain the node from the queue, whichever node is there. That is, u is equal to q of front. What is q of front? Q of front is 0. Then increment the front by 1. Front plus plus. So front will be incremented and made it to point to next node. Now we have got some node u. We have got some node u and we have to repeat the connected. That is, we have to visit the next node starting from the node u. Starting from the node u. For v equal to 0, v less than n, right? For v equal to 0, take one more node. One second. For v equal to 0, is v less than n? What is n? N is equal to 4. So 0 is less than 4. Condition is true. Check this. If this both the conditions must be true. What is adjacency of uv? What is u? U is 0. V is also 0. What is adjacency of uv? Is it equal to 1? So go to adjacency matrix. Adjacency of 0, 0. Adjacency of 0, 0. What is 0, 0? It is 0 only. Adjacency of 0, 0 is 0 only. That means this condition is false. Once this condition is false, you no need to go for other condition. Then this part will not execute. This part will not execute. Right? Then value of v will be incremented. So v will become 1. Again check the condition. 1 is less than 4. Condition is true. Check this condition. Adjacency of uv. U is 0 and v is 1. U is 0 and v is 1. Is it 1? 0, 1, is it 1? Yes, check the adjacency matrix. Adjacency of 0, 1, is it 1? Yes, it is 1. And visited of 1, is it 0? What is visited of 1? Visited of 1 is 0. That means the node 1 is not yet visited. Both the conditions are true. This is true and this is also true. and both the conditions are true, we will visit that node. That means increment the rear by 1. In that location, store the value of v. What is v? V is 1. So q of plus plus is equal to rear. What we do? Rear will be incremented to make point here. Now rear will not point here. Rear is pointing to this location, and in that location, copy the value of v. What is present in v? In v we have 1. So 1 is written. Then print that as the output. Why? Because whenever we visit the node, we are printing that node. So what will be printed down to the output? 1 will be printed down to the output. Next, make that visited of v equal to 1. Visited of 1 also 1 you should make. Instead of 0, now it will be made as 1. It will be made as 1. Right? Next, go for next iteration of the for loop. Increment the value of v by 1. So now v becomes 2. Check the condition, it is true. Adjacency of 0, 2. U is 0, v is 2. Adjacency of 0, 2, is it 1? Adjacency of 0, 2, is it 1? Yes, it is 1. It is 1. And visited of 2, is it 0? Visited of 2, is it 0? Yes, it is true. Both the conditions are true. Again, enter into the if statement. Increment the value of rear, and in that location write the value of v. Q of plus plus rear. First rear will be incremented. Then in this location, what you have to write the value of v. What is present in v? In v we have 2. In v we have 2. Then make that visited of 2 also as 1. Visited of 2 also as 1. This entry will be made as 1. So I'll erase the 0 and I'll make it as 1. Now again go for next iteration of the for loop. Increment the value of v. So v will become 3 now. Condition is true. 3 is less than 4. Condition is true. Check this. Use adjacency of 0, 3. Now v becomes 3. Adjacency of 0, 3. Is it equal to 1? Adjacency of 0, 3. Is it equal to 1? Yes, it is true. Check this condition and check this condition. Visited of 3. Is it equal to 0? Visited of 3. Is it equal to 0? Yes, it is true. That means that node is also not visited. Then increment the value of rear, and in that location write the value of v. Q of r plus plus. First increment the value of r. Now r is pointing to 3, and in that location write the value of v. What is present in v? In v we have 3. Then print that value of v. One second. Last time I forgot to print it here. 2 we must print. Now value of v is what? 3. 3 also will get printed. Next, make that v also as visited. Visited of v. What is v? V is 3. Visited of 3, make it as 1. Instead of 0, I will make it as 1 now. Right? Instead of 3 is also made as 1. Now repeat the for loop. Increment the value of v. Now v becomes 4. If 4 is less than 4, condition fails and will come out of the for loop. Will come out of the for loop. Now this is what is list of nodes visited. So what are the nodes output? From 0, 1, 2, 3, all the nodes are successfully visited by using breadth first search. So if we can see here, from 0 we can go to 1, from 0 we can go to 2, from 0 we can go to 3. From 0 to 1, 1 to 2, 2 to 3. This is how the direction we have gone. What is the output we have got? From 0 to 1 we have went, then from 1 to 2, then from 2 to 3. That is 0, 1, 2, 3. Output is what? 0, 1, 2, 3. So this is the list of nodes visited by using breadth first search traversal. By using breadth first search traversal. And here we are going to make use of the Q data structure. We are going to make use of the Q data structure. Right? Now, for the given graph, now let us study. This is the same graph. Now let us study the breadth first search for this other technique. What is the other technique? See here. Case 1 was creation of the matrix that we have done. Case 2 was breadth first search, that is also over. Next, case 3 is depth first search traversal. Case 3 is depth first search traversal. So here what we do here is, again we'll consider some source node and make all the nodes are not visited. Make it as 0 first in the beginning. Visited will be made as 0. What I will do here is visited will be made as 0. Now I am explaining DFS for you. Now I am explaining depth first search traversal. What it is expecting, it is making visited as 0 for all the nodes. And visited is made as 0. Now this is where we call the depth first search traversal. DFS function will be called by using source node, that is 0, adjacency matrix, visited, that is 0, then n is the number of nodes. Now finally, after coming back, what we check, if is there any visited of I is 0, that means is there any node which is not visited? If is there any node which is not visited, then what it indicates, flag is 1. If flag is 1, what it indicates, the graph is not connected. Else what it indicates, the graph is connected. Now let us see the DFS traversal. The control will get transferred to the definition of depth first search function now. So I'll go to the definition of depth first search function. This is what is depth first search function. I'll copy this and I'll paste it here. So that it will be easy for the explanation. Right? So visited is made 0 here. And meanwhile, once I can just download it. Okay, let us see how a depth first search works on. It is going to make use of stack. So basically it is going to make use of stack data structure, not the queue data structure. Right? Now, adjacency matrix is known to us. Adjacency matrix is known to us. What I'll do here is I'll write the adjacency matrix once again here. Else it's not required. Now we can see from here. Here it is there. 0, 111 adjacency matrix is already available. Then visited is already which is also available here, and that is made to 0. What it indicates, the nodes are not visited. Now k as a local variable, then make visited of source as 0, because we are considering source node as src was given as 0, and make visited of 0 as 1. Because anyhow you are starting from node 0 means that is visited first. I'll visited of 0, I will make it as 1. Visited of 0, I will make it as 1. And print that source node as the output. So I will write output here at the end. What? 0 is visited. Then for k equal to 0, k less than n, k plus plus. So start k from 0, k is less than n. Is it true? Because what is value of n? N is 4. 0 is less than 4. Condition is to enter to the for loop and check what is that? Adjacency of src k. What is source? Source is 0. What is k? K is 0. Adjacency of 0, 0, is it 1? So what is adjacency of 0, 0? So instead of going there again and again, I'll rewrite it. And it will be some time consuming process, but you will understand the things in a better way. So I'll write the adjacency matrix here. 0, 1, 2, 3. 0, 1, 2, 3. What is the matrix? 0, 111, then 00, 10, then 001, 0100. Right? Now check the condition. Adjacency of 0, 0, is it 1? Adjacency of 0, 0. Is it 1? No, it is 0. It is false. Will not enter into the if statement. Then increment the value of k later. So now k becomes 1. Condition is true. 1 is less than 4. Condition is true. Check this condition now. Adjacency of 0, 1. Source is 0 and k is 1. 0, 1. Adjacency of 0, 1. Is it 1? Adjacency of 0, 1. Is it 1? Yes, it is 1. Condition is true. And visited of 1. Is it 0? Visited of 1 is also 0. Both the conditions are true. That means we will enter the if statement and we will call the DFS once again recursively. We will call the DFS once again recursively because we are going to make use of stack data structure and it is the recursive call here. Now in place of source, now this will occupy the place of source. That means what becomes source becomes 1 because value of k is 1. Then as usual adjacency matrix visited array and n will pass. When this recursively gets called once again, the control will go to this place. Now what is the value of source? Source is 1. Adjacency matrix is as it is. Visited array is this one and value of n is 4. Now the function will get called once again with the value of source as 1. The value of source as 1. I'll erase these parts. Right? Now let us see. The source is 1 now. Why source is 1? Because the value of k was 1. Now we are starting from source as 1. As usual, visited of 1 you make it as 1. Visited of 1 make it as 1 instead of 0. I'll erase this and I'll make it as 1. Visited of 1 also as 1. Then print that source. What is source? Source is 1 now. Print it in the output. So on the output we are printing 1. So earlier we had printed 0. Now it is 1. Now again repeat the procedure. Same procedure. What is that? Initialize k with 0 and n is 4. We know that 0 is less than 4. Yes, condition is true. Check this. Adjacency of source k. What is source? Source is 1. K is 0. Adjacency of 1, 0. Is it 1? Adjacency of first row and 0th column. Is it 1? No. False. Don't enter. Increment the value of k. K becomes 1. 1 is less than 4. Condition is true. Enter into the for loop. Check now. Adjacency of 1, 1. Because k has been increased to 1. Adjacency of 1, 1. Is it 1? Adjacency of 1, 1. Is it 1? No. Condition fails. Right? Go for incrementing. Increment the value of k. K becomes 2 now. K becomes 2. Condition is true. Now check. Adjacency of 1, 2. Now this becomes 2. Adjacency of 1, 2. Is it 1? Adjacency of 1, 2. Is it 1? Yes, it is 1. Adjacency of first row, second column. Is it 1? Yes, it is 1. Condition is true. Check again. Visited of 2. Is it 0? Visited of 2. That is also 0. Both the conditions are true. Now you call once again what? The recursive function. This function will be called. This time what is the value of k? K is 2. Now that becomes the next source node. This 2 will be copied to this place. Now source becomes what? Now our next source is what? 2. Next source is what? And 2 and the same procedure will repeat. Next source is what? 2 now. The same procedure will repeat. I'll erase it. I'll erase everything for fresh explanation. Right? What is source now? Source is 2. Again everything remains same. Then make that visited of 2 as 1. Make that visited of 2 as 1 because now when you go to that node that will be visited. Make visited of 2 as 1. Print that node. What is present in SRC? SRC we have to print it. Print it. Now k equal to 0, k less than n, k plus plus. Again start the same procedure. K equal to 0 and n is 4. This 0 is less than 4. Yes, condition is true. Check this condition. Adjacency of SRC, 4. What is SRC? Source is 2. What is K0? Adjacency of second row, 0th column. Adjacency of second row and zeroth column, what it is? Adjacency of second row and zeroth column, what it is? It is 0. Condition is false. Yes, don't enter. Increment the value of k. K becomes 1 now. Again check the condition. Condition is true. Now check this. Adjacency of 2, 1. Is it true? Adjacency of 2, 1. Is it 1? Adjacency of 2, 1. Yes, it is 0. It is false. Don't call the recursive. Don't enter this statement. Go for incrementing the value of k. Now k becomes 2. Again check the conditions. I'll erase this, else it will get confused. Yes. 1 second. Yes. What is the value of k now? K is 2. Adjacency of 2, 2. Is it 1? Adjacency of second row, second column, what it is? It is 0. No. False. Again increment the value of k. Make it 3. Adjacency of 2, condition is true. Why? Because 3 is less than 4. It is true. We will enter into the for loop. Adjacency of 2, 3. What is k? K is 3. Adjacency of second row, third column. Is it 1? Adjacency of second row, third column. Is it 1? Yes, it is 1. Condition is true. Check the other half also. Visited of 3. Is it 0? Visited of 3. Is it 0? Yes, it is 0. Both the conditions are true. We will call the DFS function once again recursive. But in this case, value of k will be passed. What is value of k? K is 3. Now that becomes the source for the next iteration. So now what I will do? I'll erase this and I'll write here 3. Source is 3 now. And I think I'll erase this. Or everything I'll erase for fresh explanation. Right? Okay. Now source is 3. Again repeat the procedure. K is equal to 0. Before that we have to make visited of source as 1. What is source? Source is 3. Visited of 3, make it as 1. Visited of 3, make it as 1 instead of 0. Here is 0 and I'll make it as 1. Right? Now print that source onto the output. This is what is the output screen. 3 will get printed. 3 will get printed. 0, 1, 2, 3. Now start from k equal to 0, n is 4, which is known to us. Is 0 is less than 4? Yes, condition is true. This condition is true. N is 4. This condition is true. Check this. Adjacency of source is what? 3. Adjacency of 3, k is what? 0. Adjacency of 3, 0. Is it 1? Adjacency of third row, 0th column. Is it 1? No, it is 0. Don't enter. Right? Leave it. Go for incrementing the value of k. Now k becomes 1. Right? Check the condition. Adjacency of 3, 1. Is it 1? Adjacency of third row, first column. Is it 1? Yes, it is 1. And visited of k. Visited of 1. Visited of 1. K is 1. Visited of 1. Is it 0? Here, visited of 1 is already 1. That means it is false. We will not enter because already all the nodes are visited. Again, we go for incrementing the value of k. K becomes 2. Check. 3, 2. Adjacency of 3, 2. Is it 1? Adjacency of 3, 2. Is it 1? No, it is false. Increment the value of k. K becomes 3. Adjacency of 3, 3. Is it 1? Adjacency of third row, third column. Is it 1? Adjacency of third row, third column. Is it 1? No, false. All the conditions are failing. And finally, we will increment the value of k once again. K becomes 4. Check the condition. Is 4 is less than 4? No, condition fails. We will come out of the for loop. Once we come out of the for loop, the iteration or the recursive procedure of depth first search will stop. And finally, what is the output that we have got? Output what we have got is all the nodes which are successfully visited. That is 0, 1, 2, 3. This was other function of the depth first search. And here what it will print? It will print as graph is connected. It will print it as graph is connected because all the nodes are visited here. For every value of n, for starting from I equal to 0 to n, what we have got now? There is no node which is not visited because everywhere it is 1. I'll show you. Yes. For all the nodes it is 1. For node 0 it is 1. For node 1 it is 1. For node 2 it is 1. For node 3 it is 1. That means this flag will not become 1. It will remain 0 itself. That means this statement will get printed. The graph is connected. The graph is connected statement will get printed, and finally 4 is exit. Finally 4 is exit. So if possible, preferably I'll try to show the demonstration. So meanwhile, parallelly, all of you practice the programs, and I hope you have completed writing the journal. Any other questions you have? Meanwhile, parallelly, you can ask. We can utilize this time for discussion. Anyone has any questions to be asked? Right. So this is the 11th lab program, which is already explained just now, and that I have pasted it here. I'll just run the program. For that, you should be able to have your this adjacency matrix. This is the input for your program. This is the input for your program, and starting node is also the input. Yes. So first thing is program to perform graph operations. Program to perform graph operations. Right. So what I'll do, create a graph of n cities. First you have to create the graph, choice 1. Second choice is for BFS. Third choice is for DFS. Then fourth one is exit. So first let us create the graph of n cities. So I am giving choice as 1. So it will ask, enter the number of cities. How many cities are there, or how many nodes are there? 4 nodes. Enter the adjacency matrix. So this adjacency matrix you have to give as an input row wise. 0 1 1 1 0 1 0 0 0 1 0 1 0 0. This is how you have to give. Please remember, input you should give row wise, 1 row at a time. That is how we give input for the program. So what is the adjacency matrix? 0 1 1 0 1 1 1 0 1 1 0 0 1 0 0 0 1 0, then 0 0 1 0 1, then space 0 1 0 0. This is a matrix. 16 entries are given. Press enter. Now the matrix has been successfully created. We have successfully created the matrix. So this is how you must be very careful while giving the input. Exact adjacency matrix you should enter. Now I'll give choice 2 to print reachable nodes from source using breadth first search. I'll give choice 2 for breadth first search. Enter the source like what we have discussed just now. 0 are the source node. I'm giving 0 as a starting vertex. And what are the vertices visited? 0, 1, 2, 3 are the vertices visited. Now let us give choice 3. Choice 3 to check whether the graph is connected or not by using depth first search along with printing the nodes. So I will give choice 3 for depth first search. Enter. Enter the starting vertex. I'll give as 0. As you can see here, the number of nodes here I should give one space, which is not there here. You can use space later. 0, 1, 2, 3 are the visited nodes, and what it says, the graph is connected. What it says, the graph is connected. Why? Because this particular graph is connected, whatever input we are giving. So where is that graph? This graph is connected. What is connected graph? You must be, each and every node must be connected to at least one other node. That means you should be able to reach that node. That node should not be isolated. No node should be isolated. For example, for this existing graph, if you write some other node here like this 4, then this entire graph becomes disconnected graph because 4 is not connected. If you give any such input, the output will be shown as the graph is not connected. And finally, what is the choice? Choice 4 is for exit. Choice 4 is for exit. And done. So this was the sample demonstration for the 11th lab program, graph and its operations. Graph and its operations.